Hello, I'm Philip Burton of SQLintro.com, and in this week's question we're continuing from last week's question. Daniel asked, how do I handle big amounts of data, like in a poll of what party one would vote for, or what brand of cheese one would prefer? For example, there could be 6 to 10 different choices of cheese, and then you rank them from 1 to 5. Now in last week's video we did a table like this, so it's got one person's choice over 5 rows with dates and other things that can uniquely identify them, their choice of cheese, and a rank from 1 to 5. And we created a pivot table for those. Now the problem with this, and the advantage, is that each individual item is unique. But that means we need to put the same person's name 5 times. But the advantage is each row does not depend on any other row. So row number 4 does not really depend on row number 3 or row number 5. It has all the information you need. But that's not necessarily the best way to do it. This is a common way used in databases and is called the second normal form. You could argue this might be the third normal form, but this is the way in which each individual item is recorded individually on separate rows. But what you might also get is what's called first normal form, and that's where you have all of the data on one particular line. So we have cheese number 1, cheese number 2, cheese number 3, and so on, all the way to cheese number 10, and then we have a series of rankings that people have got. Now I'm just going to, for this demo data, also have a few other columns over here. Now they're going to tell me out of 1,000 or even out of 1,000,000 how well people like that cheese. So it's really to be used for creating this fictitious data. So I'm going to create a table, Control and T or Control and L. So there's my table. Right, over here I'm going to use the ran between function that we saw previously in the previous video. And so is that many? No, one more 0. So here the computer is saying, okay, how much does this particular individual like this cheese out of 1,000,000? Because what I'm then going to do is use this individual's top 5 choices to rank 1, 2, 3, 4, 5. When you are creating a system, it's always good to have some dummy data, and this definitely is dummy data. Right, so now we know how well this individual liked it out of 1,000,000. Now we've got to allocate the choices 1 to 5, Eurovision Song Contest style, except the reverse, 1 being the best. And we do that using the command rank. Specifically, we've got 2 versions in more modern versions of Excel, rank.eq and rank.avg. And you can see the difference between these two. What happens if there are ties? Do you want, like for instance, say 2 people tie for, or 3 people tie for 3rd place. Do you want them to say that they're all 3rd? Or do you want to take the average of 3, 4 and 5 and give number 4? So most of the time I'll use the top. Right, so what position is this number out of all of these numbers? And then I want it in ascending order. I want to rank the list in ascending order. So there's my rank. So you can see that currently, actually I want it the other way around. This one is actually the best. 802 is my best, so I want it descending order. So I'll change that to not. There we go. So now, and then because I want to actually type this in as M2 and copy that across, there we go. So now we've got this cheese number 1 is the top of all of these. 847, 647 is the highest of those, and then this is the 2nd, that's the 3rd, and so forth. Now I don't want it to show anything if they're 6th or 7th. So first of all, I'm just going to simplify this down into this sort of reference. Exactly the same result. Right, now if it is greater than 5, then I don't want it to show anything. So this is how we get the ranks. So now we've got rank 1, 2, 3, 4, 5. Now before I continue, let's just have a look at those formulas again. So ran between gives a completely random answer between the two values you give, 1 and a million in this case. And rank EQ, so it's the rank bit, it says where is S2 in order of all of these values, and 0 for descending, so the biggest one comes first, or 1 for ascending. Right, so now we've got all of that, we just now change the design so that the table is now, let's say, 800 rows deep. That will give us 4,000 data points, 801 rows deep. Here we go. So you can see that all of this has been caught downwards, it's filtered downwards. These haven't. You can see something skewy has happened to the formula there, so I'll just press enter again. There we go, and copy that across. Right, that's better. The great thing about the table is it allows for consistent formulas. So you can see I'd only had to type in the formula in one row and it went all the way down. So now my question is, and I'll just insert some rows above, okay, how many times did this particular cheese come in first, second, third, fourth and fifth? And for that, I'm going to use a simple SUMIFS. So, even a count if. So I'm going to count this particular column, which I can do like this because it's a table, or I could say C8 colon C and 808. How many times it meets that criteria? And you can see 75 times. Now the only thing I have to do is to put dollar signs here, here and here. So dollar sign fixes what's immediately above. So I always want to talk about rows 8 and 808, and I always want to talk about column B. So now when I copy all of this across, then I'm always talking about 8 and 808, no matter how many rows down it is, and I'm always talking about column B. But there's the answer. So perhaps it might also help if I put on, say, some conditional formatting, and I'll use color scales, where green is the top. There we go. So you can see the fast choice there in the one that most people agreed, cheese 6 was definitely number 3, rank number 3. Now if I remove that and we just have a look at the top row, you can see that we've got a sort of tie for first place. Cheeses 2, 3, 5, 7, they all seem to be vying for top place. If I just randomize this, there, now we've got cheese 2 at top place. So this is another way of doing this analysis of quick data very quickly, of big data very quickly indeed. So here we can see COUNTIF translated in all of the different languages. First of all, we have a range and then what we are looking for. So that is how quickly you can do this analysis. And we've also had a look here at rank to get us some dummy data, along with ran between. So I hope that answered your question, Daniel. This is how you can quickly do analysis of big amounts of data.